Hello?
Hello.
Hi, how are you?
Okay.
Good.
Can you hear me okay?
Yeah, I can hear you.
Ooh. Okay. Okay, I think I could be on camera in a moment. My computer sort of had to do a bunch of updates. It's
Oh,
kind of
yeah.
funny. I never have that happen, but then it was like, the update monster finally.
Yeah. Update monster. That's a good way to put it.
Yeah, better to appear.
Yeah. Well, welcome to the meeting. Um, welcome, Jesse, and we have people watching online. Um, Akshara contacted me and said she can't make it today, but she wants to do the presentation maybe on, asynchronously, so she'd record it and then we'd play it in the meeting or something like that. So that's perfectly fine. She wanted to do a paper on her area of research. So it was looks like a pretty good paper, but I'll let her present on that when she's ready. And so she's getting subjects for experiment, which is good. She's collecting data. Have you heard from Anson lately?
Yes, but he's very he's not able to focus on this right now. So he's okay, but it's he hasn't really been able to do as much as he wanted to. So
Yeah. Well, hopefully he's doing okay. I haven't seen him in a while. I was wondering if he's doing better, because I know you said for a while there he wasn't doing very well. So
yeah, he's coming along, but it's sort of he doesn't have a lot of extra bandwidth right now, and he his mind and his desire for all of this stuff it remains, which is his capacity is not there in so many words.
yeah, yeah. So good. So how are you doing this week? What can you provide an update, or I don't know. I know you have a notepad here that we've created. We created it in Slack.
Yes, we have, and I figured I'd try out some stuff. In part, I don't know. Do you want me to show the notepad? Or,
Yeah, yeah. Go ahead.
the shared copy of it. Let's try this. That's okay. Some things that are set on my computer. Because they share audio. I never saw that button images before. Anyway, I'm not going to do that. Application window. I think this is what I need. Okay, is this working?
Yeah, there it is.
Interesting. Okay, all right, that works. So I made this week, and then the comics there's a lot of different updates I had. This is kind of a tentative thing, but just to kind of show this, I kind of wanted to have a space where we could share our notes and write this here. I pre-populated with these general category headings, but anybody in the meeting in the lab can come here and write in this. And I know, not everybody can be. I don't know if this is you or Danielle or whoever else this is, but
Yeah, it's probably Danielle. I'm not in it.
Okay, well, if she's here listening, hi Danielle, you with us in spirit. Editor, Danielle,
Yes.
you can speak to that. Um, but uh, I wanted to make this because I saw two needs, and the needs were one, how do we make this more streamlined and maybe even more inclusive? Because I'm okay with writing this stuff, but if people want to say, if people want to highlight something and write it themselves, you can be a quote unquote. It's not as prestigious as a paper, but you can be a co-author on this if you like. Like this isn't like something that only I can do or only Bradley can do. So feel free to contribute actually to our Medium notes and templates, and this is kind of becoming. I think Medium as a kind of template or minutes for the lab is important and useful, and like being able to go back and look at our previous stuff, I think is helpful. And we put out the newsletter, and it's sort of just a way of a little bit of administration, but also capturing the tone of verbs themselves. It's kind of an exercise, in and of itself. Not the biggest thing in the world, but kind of a cool thing, and also opportunities for people to be involved if they want to be. This is the template down here. I kind of, put this over here. And I did mention this just so people, just to have it here. That's kind of what we typically do: updates, all business, and deadlines and stuff. And then some, we kind of close out with this sort of stuff. It's not fixed, but just have it there. So I'm probably going to be taking notes, in these parts here, and I may try to refresh this every week, and I feel like there's a way to. I don't know. I haven't yet decided if I want to make a new document every week or just sort of copy. You make a copy of this and then save the copy, and go from there. But
Yeah.
Hopefully, it's a way to do that. So, in the context of my updates for this week, this is something that I've done, and I also made some things on GitHub that might help structure things for myself. So, in general, this week, I've I don't have Slack here. Let me consider the following. Bill has that very well. Consider the following. I wonder if this looks funny. Does it look funny when I do this? Like, does that seem intelligible?
Yeah, it's fine. Okay. We have our Slack.
Yeah. One thing in Slack, I made this. I made some updates to this column. And I'll just show you that here now. This is our Saturday meeting board and task board basically. And I don't think it's quite here yet. But I updated this a little bit. I doesn't go through this. But I made this column just put some stuff to do here. Because I think it kind of helps a little bit. But again, this is sort of, down in the weeds sort of thing. What I've done this week has kind of been, go back to slide here, has been, this stuff. I worked with some of the abstraction metrics, and I imagine you're going to talk about the surge abstract later, right?
Yeah, we can do that.
I don't have a lot to say about any of these things, but I've done some work with that, and I don't have as big as an update for the Ethics Society. I mean, I can talk a little bit about it again, but this has kind of been my jam. Everything there is pretty much very true for me. And I had a bunch of ideas yesterday about this, and I sort of implemented some of them. So I don't really know where to begin in that sense.
So what do you show? Is there like an integration, or is it just on the board, or what is the?
Well, I'm kind of, nothing is really particularly new on the board. On this board, I have made, and I guess I'll show this for now. If anybody wants to do this, you can make a private task board if you're using GitHub. I made one here. There's nothing like too private here. It's just tasks that are already existing elsewhere on the site. But I've made some. It's like a specific view for myself that I think will help me with some ideas, because there's a lot of things here that I want to do, and they're kind of lost among various projects and whatever else. And I feel like if you're going to use GitHub to do project management, it's because you can have, like, for example, I did make this as well within Ethics and Society. I made a project which is about a collection of computational models of ethics, which I'm going to here. This is kind of a new thing. I've done a little bit of work on this page in general, in this repo. I've also included essentially the abstract, and I'll make some more open paper related stuff here. This is our abstract right now. For this presentation, which we talked about before. And for those who don't know, we're just coming into sort of we have a few people who are in the Ethics Society team, which is still maybe an updated name, but we submitted to this conference, New York's Coalition on Computing. We are going to it's not letting me show that. I think. We've submitted a research presentation, which I can't quite seem to show the thing about, but hopefully it'll be accepted. But if not, this is something I'd like to flesh out either way. And it'll be a 20-minute, more like 15-minute presentation about the challenge of creating ethical frameworks for AI or AI ethics. And I go into some of the details here. But that will be ongoing, and we kind of have the next month. We have most of February and March to kind of flesh that out if we get accepted for that. But this is something that I've wanted to do for a while, and I bring in some collaboration on it. I don't think Min's going to be here today. Angela may join us at some point. I think Daniel expressed interest as well. So there will be some work that I'm pushing out regarding this, and you can see some of the updates here in this repo. But what I wanted to say also, like, for those of you who are curious about using GitHub in a project management sense, if you make a project within this, like this is within this repo right now.
Yeah.
The project will be here, and it will contain things. It will kind of. This project will not exist on the main page, but it's from within it. But what's good is that anyone, like, why I made this private view for myself, is that I'm trying to aggregate a lot of my. The bigger story is I have a lot of projects to manage in my life, and this is a common theme in academia, and a lot of people who are doing a lot of amazing things. And I'm experimenting with this view. I may not use it, but my current experimentation is by making a project in the top layer of oral groups, and I made it private so that only I have access to it and everything else. You can easily incorporate stuff from everywhere else. Like this is not for the project's dependent. So I mean, I don't expect everyone in the lab to be doing this. It's a little bit overkill, but it helps me to find what am I specifically going to be doing, you know, and look at it that way. And I have been looking at integrations between like Notion and some other apps, and part of me really would like I would love there to be like I almost kind of wish there was a way to use Trello that would like work with GitHub better and a little more accessible and would integrate with other things. But it's just it's sort of like on the precipice of what works for the lab is what works for me versus currently it's mostly just myself doing this stuff anyway. So that said, I did get I think I did invite Daniela in GitHub, and so I think she saw that. I don't know if she's here or not, but that will help with a few things as far as integration here. And I did make this as well. Like I've started creating like a specific. You can create. This is actually a specific project that it's going to have very specific, things that I'm doing. Like this will not be an open-ended board, especially an actual project board. And to that end, these are things that I'm envisioning about doing. I have a presentation about this, and we don't have to talk about this right now, but I might go over what I'm envisioning in this project board when the time comes up. So it seems kind of, I can talk a little bit more about this at some point, but I don't know if now's the right time to do that. So,
yeah, I mean, we can probably do it another time. I don't know, how long do you think it would take to go into it?
Less than 5 minutes at this point.
Well, why don't you go into it? Yeah.
Okay. Then I will, and we can probably, I don't know if you want to go through this, or what did you envision for the course of today's meeting?
Well, I was going to have you give an update, and then I wanted to go over last meeting's things, and then add a couple things that I wanted to present. But, we can do this first, and then...
Okay. Just so people, I have yet to make a, this is actually in progress. I basically have the team set for who wants to, people are welcome to join. But what I want to do with, like Min and potentially Angela and Danielle, I have a variety of subtopics that I want to focus on within the presentation. And I mentioned them in previous meetings, so I won't go into them entirely right now, but I'm looking for people who have specific points of interest that they want to research. And then we can aggregate them into a presentation. 20 minutes is really going to be, or 15 minutes really won't be that much, because there's so much stuff to cover. But, this is sort of an adjacent thing that I put here. I do want to have, I've already envisioned a little bit of moral theory and philosophy that I'm going to put into this. We're going to talk about this here in the lab right now. But I think as I kind of mentioned in, I guess it's the last meeting now, but I basically see artificial intelligence ethics as an equivalent in the same way that we look at how our machines collections of ways that humans think. I think when we put ethics to it, it's a way for us to examine our own ethics, and I think that's a gigantic civilization, planetary level problem that's not should be trivial in any way or trivialized in any way. So I'm not trying to say this is solving the universe's riddles necessarily, but I think having an articulate way to approach that. And frankly, like, when I see people talk about most of the presentations that I've seen about AI ethics frameworks and like really high level stuff at like IEEE or these sort of things, like they tend to be either very big and not. I know you have to be very kind of inherently broad about stuff, but I would like to really take not many minutes during the presentation, but some minutes, and to lay out some of the conundrums that we're dealing with in a very particular way. So that's why this is here. And then there's some other plans that I want to do. Ultimately, I'll be putting some of the cards for like, like there'll be obviously something about AI bias for sure. There'll be something about facial recognition, like probably like Planet Palantir, which is something we talked about in some previous work, both at New York Celebration on computing and other things. There'll be talk about incorporating different like current issues and different developing issues into this topic. So that's all I wanted to say about this. But this is something that's in development and in progress and in the works, and I'm very happy to have that as an outlet for stuff. But there will be some other more ahead with that. But there's some progress in there.
Good.
I'll leave it at this. Yeah, I'll turn it over to you.
All right. Well, thank you for that. That was very good. And so we'll be following up on that. And I like the way you organized it. It's always good to see new modes of organization. And so, yeah, let me actually make a comment on the notepad that you have. So could you bring that back up? Or there we go. Yeah, so I like this layout. Just keeping notes in this, and then a lot of people will put these in like in sequence where they put it in for each week successively so that you can access past weeks. But the thing is, it gets unwieldy because you have to scroll through like 10 pages eventually or more. And so, one way to do it is maybe to put in the outline, make it clear what the date is, or there's got to be some way to do this, and I don't exactly know what it is. We could even make these minutes like, close them out after like a week or so and put them somewhere, archive them, and then people can, select a week where they're interested in looking back. And I like the idea of being able to keep it open for a while so that people can give their input. And then putting that to the medium, because the medium is a one-way sort of a broadcast to people, but this would be more of an interactive thing.
Yeah.
So,
yeah, I mean, there's sort of the ideal world where everybody is sort of contributing. There are many people who are like, distributed and not directly here, but still contributing stuff in the lab. And it'd be great to kind of offer them a little bit more interactivity with what we're doing, with sort of where this comes from. But at the same time, it's not sort of. I would like there to be some kind of buy-in, but I don't know if there will be, and that's okay.
Yeah.
So it's sort of an experiment in it. It's an experiment in both accessibility, but also like the stuff that are right here. And maybe it's awkward to have this here, but I literally just sort of copy paste something here and then touch them up and make it a bit more readable for a general public, and then publish it, and then I'll be it. So
Yeah.
that's sort of it.
Yeah, I think that's great. And then we still have the twirly bird notes, and I don't know what the end point for that is in terms of the pipeline. Like, so we just had those notes, and is there a way to make those public, or do you think that we can archive those somewhere where people can get access to them? Right now, I have them pinned in the Slack channel, but that's not really a great permanent home.
What do you, where do you mean they're pinned to?
Well, I mean, I have the for example, we have the notes from NeurIPS, the twirly bird notes, and it's somewhere in there, and I think it was posted to one of the Slack channels, pinned to the top of the Slack channel, so people can access it in Google Doc format. But other than that, it doesn't. It's not really accessible. So what do we want?
The shared documents for
the shared documents. So can we archive those, or can we publish those somewhere, or what? What do you think?
That's a good question. I haven't really considered entirely what to do about that. I want to actually put a thing here for that. I don't know, because I feel like in an archival, almost library sense, that's an interesting question. And how much do we want? Obviously, we're an open lab, so writing in a notebook isn't really. I don't think it has too much private information in that sense. But I think there could be a way. I think there could also be a web page somewhere, maybe on the oral website. So there could be, you could create an ideally auto-populate rather than manually do, but you could create a list of all of the meeting notes that we've written, the whole the medium meeting minutes or recaps or whatever, and maybe in the same spot have this sort of list of maybe the documents themselves, the shared documents, just to kind of have them there, as opposed to them being just totally not ever seen again, but having a known location to just kind of store these things and add to it might be good. And I haven't really thought about that entirely, but that would be something to think about.
Yeah, definitely. Because it's we put a lot of effort into it, and it's then it gets lost. So it's well, this is great stuff, but what do we do with it? I mean, eventually, we'd like to make works, derivative works from it. So going back to the notes, oh, this is great, we should follow up on this, or this is something that we can do in the lab. There are different things that we want to do. So, but if we can't access them, maybe a year from now even, then it's kind of works against us. So I think that's good. So yeah, we'll think about that. So thanks for sharing your screen. I'm going to share my screen now. Okay. And I'm going to go over some things here. All right, can you see my screen?
Yeah.
All right, so the first thing we have is we'll do kind of a quick Slack review. So we have the Brain Organoids channel, which has been very active with Morgan, and he's been posting a lot of materials. And I've been trying to download them and make a little library out of them. It's a lot of stuff in here. If you haven't joined in this channel, this is a great place to look for things. And this is organoids, stem cells, regenerative medicine. So it might be over some people's heads a bit if you're coming from an area like philosophy or even some areas of neuroscience. But we've been trying to figure out how to sort of provide an educational layer for this stuff. So, there's a lot of interesting stuff going on, and of course there are links to lectures, which is a good way to, get up to speed on this stuff. And then there are there's the stem cell podcast, and this one on water-induced pluripotent cells and iPS cells. So all these things are, if you want to learn about this topic, this is a great place to go. We're still trying to organize this into a better, educational experience, but that's something that's coming up. I think Morgan's putting a lot of good stuff in here, though. Also some stuff on EEG measurement, which is Morgan's primary area. We're also looking at data, like this is having a data science angle. So we've been talking about data sets for these things. And so there are open data sets that if people are interested in using for whatever reason, there's a data science aspect to this as well. So we have call for involvement, which we didn't really update very much, but we've been updating the medium, so we've been putting out the posters on the medium. That's open. Open channel. Let's see. We have the Cog Futures channel, which has been Jesse's been posting on various topics here. And then let's see. Conference materials is this is where we're putting all the stuff for the different submissions that we're making, abstracts. Been doing some updating on that. Hasn't been much to update recently because we're kind of releasing things in this channel as we go along. And I've been communicating with some of you privately on that. So the next big thing that we have coming up is we're going to take the developmental AI paper, which we'll talk about later, and we'll turn it back around and send it out to AWIFE 2021. So I'll mention that in the channel in the next couple days. Cybernetics is we've gotten some updates on that. It's just a matter of getting people interested in this topic. I put out a poster for the call for involvement on Twitter, on the Medium, and now in this channel, this is the channel you would join for that. And I had a cute little picture here of the cybernetic rabbit hole. That's, it's something fun, but it's not academic. But we have some topics in here we're talking about, and hopefully this picks up a bit. Then we have the Developmental AI channel, which is this thing about the Developmental AI topic that we talk about a lot in the group. So we've got some nice links in here. We haven't really had a very much conversation on it yet, but we'll be adding to that in the future. Let's see. Ethics, Society, and Tech. Again, this is Jesse's project, and we have some good posts in here. We've covered some of these papers in the meeting. So this is the abstract for the workshop. So, when we're doing shared documents like talks or abstracts, it's nice to post it in the channel and open up the sharing permissions so that people can get easy access to the link. And then if there's something you want to highlight, you can do this. You can pin something to the channel. So you click on these three dots for something and you go to pin to the channel. And then it shows up. Let's pin this one, for example. Or actually, let's pin this because this is kind of important to the channel. So let's pin this, and you can see it shows up here with this little pin and a 1 by it. If you go here, you click on it, it shows you this pinned category. And I don't know how many things you can pin at once, but it's pinned now to the channel. So all you have to do is click on this, and you can see the most relevant content. That's nice. I think that's a good way to organize. We've done this a lot in different channels, but I wanted to point it out to people. Let's see, we still have research questions, which hasn't been posted to in a while. Every once in a while we post to it, but if we have big questions we think about and we don't know, we want to get people's feedback or get people involved, then this is the place to do that. And that's a good place to go as well. We have office hours open chat for sort of managing office hours, and Jesse's been pretty active in that. So I just wanted to point out some of the main Slack channels that we have and kind of go through a little bit of that. Just it makes it a little bit more salient to people who, if I talk about Slack in the abstract, it's kind of hard to follow it. But do you have any thoughts on that, Jesse? Or
no, I think it's good to do an update of that. I don't know if you want to do any other updates about submissions or, I mean, there's some stuff on the project board, but not anything that's not,
coming up very quickly that we need to.
Yeah, no, I think the Slack's good. I do want to do a little bit more. There's a little more to be done with some of the things that I'm working on in Slack, but yeah, it's good.
Yeah. So yeah, I will turn to the submissions next. So let's see. We'll do the submissions. So this is the submissions sheet. It's a little bit longer than before because we're finishing things off and grading them out, and then we're adding things, so it's getting longer, but we're getting more check marks in here, which is good in this column, the deadline column. So we have, I couldn't find anything about the OHBM Twitter conference. It may not be happening this year, but we need to keep checking this website. I'm not really sure what's going on there, but the allostasis machines paper has been submitted to the SIGCHI workshop. So that's off, and we'll be hearing back from them in maybe a week or two. Hopefully we were submission number 1, so hopefully we get into that. We have submissions to evolution, which is more a diva worm thing, but we have a couple ideas for that. This is the one I was telling you about just a couple minutes ago. This is the Artificial Life 2021 conference, and we talked about this last week. It's a conference on artificial life and history, philosophy, computation. You know, they cover evolution, they cover neuroscience, but in the world of simulation. And the deadline is March 7th. So we have to submit. We're going to submit a paper at least for this by March 7th. The paper is 8 pages long, and I got there. I downloaded the template and I put the paper in the template this week, and it's about at I think right at the end of 5 pages. So we have 3 pages that we can add to this for this submission. And this is the paper that we did, the Baby Minds paper. So this is, it's fairly well developed. It's got some missing spot. We have to add some things in about like the actual algorithm, more details about gradient descent, things like that. That was something that they were looking for in a NeurIPS audience. Artificial life will be similar. We need to add more technical detail. We need to add in maybe a little bit more. We can go through it and check. I'm going to put it in the Slack channel probably after the meeting. I didn't put it in the Slack channel before the meeting, but because I'm not really quite 100% ready to turn attention to it. So I just wanted to give people a heads up on this that's coming and start thinking about how we might add to the paper. And I think that people who have already seen the Baby Minds paper have a somewhat of a decent idea of what's in there. It's basically this idea of developmental AI, which we'll talk about in a minute. It's developing this on a developmental Bradenberg vehicles platform, and then taking that platform and looking at how, we have the different approaches. We have the Hebbian learning approach, the genetic algorithms approach, and then we also have the, which is more proposed, hasn't really been worked out as much, the reinforcement learning approach. And so it's kind of organized like that. I reorganized it in the template so that it reflects more of a traditional methods section, because in the NeuroSim submission we had to put it into an extend, or into like appendices, and so that made it a little sloppy. But you know, and then there are also these like scenarios that we build, like, you know, with respect to something called developmental freedom, where, you know, you have this network that grows in terms of the number of nodes, and then at some point it stops growing in terms of the number of nodes, but it's still reorganizing internally, and that's this developmental freedom idea. And so, you know, we may spend more time on that too, laying out what that is and reflecting more on what that is. So there's a lot of work to do there.
Yeah, I feel like there's sort of a like after we finish our sort of immediate focus, when we turn on that, like there's going to be this, and maybe this is a precursor, maybe that you're doing the developmental AI presentation today, but like I think there's this, it's like there's this sort of like build up of like developmental AI focus in the lab that's about to just like go off in that direction, and I'm excited for it. And then we got to handle all some of the business before we can do that. So I'm looking forward to that.
Yeah, I am too. I think this is I think it's a good opportunity to get this, like, just to start thinking about this more as a primary focus, because we kind of put it aside for a while, but that's also good because then you can reflect on it and you know, learn more about other things or think about other things, and then come back and say, oh yes, that's clearly right or wrong. But I know Rashab was working on the reinforcement learning part. I don't know what his current thoughts are on that.
I would like to actually work with that a little bit myself.
Yeah. And I think, well, you know, that's the part that hasn't been implemented. So we have like, and we didn't even talk about the collective behavior aspect, but we've laid out like these three approaches, and I think the reinforcement learning is really interesting because it's sort of, you know, this idea that you can have this behavioral feedback through explicit. The Hebbian learning is actually also, you know, behavioral feedback, but it'd be interesting to kind of compare those three, maybe get more into the comparison of them in terms of the implementation.
I think comparison between them, and then also maybe not quite as simple as like, oh, what you know, what future directions for it, but getting into, and what I would really like to do is like get into, you know, because this kind of fits with the cognition future stuff of like actual models of cognition, like getting to these computational nuts and bolts of what are these things able to really do or not do. And this kind of fits also with like, this wouldn't be part of that paper, but I made a note somewhere. I forget where I made a note, but like a tangential thing of like I think I made it. Maybe I didn't make it. I'm looking at the board right now, but I don't think I put it on the board yet. But,
okay.
The redundancy aspect of perception, like it very is to me adjacent to redundancy and different approaches to future stuff. So we'll come back to that some other time. But
yeah,
this will be good. I think I'm looking for. I look forward to. It's sort of like this, you know, appreciating the anticipation, but getting into that topic will be really, really fun.
Yeah. Just making a note here. So that's the for A-Life. Now that's due March 7th, so that's coming up in a couple weeks. So we have a couple weeks to work on that. Then, you know, you can also submit extended abstracts, which are like, I think 4 pages, 3 to 4 pages in their 2 to 4 pages in their format. So it's
A-Life.
Yeah, so it's an IEEE type format. So 2 to 4 pages would be like maybe 4 to 6 on a standard format, single column. So if you want to submit something for Cog Futures, or we might do like MetaBrains, put in like something on like an overview of this, let me know. We can put something together. Like an extended abstract, I think is easier because there isn't really this push for like rigor. I don't want to make it sound bad, but like it's not as it's not as the full paper like as what the full papers are like. So it's definitely something we can think about.
Yes.
So then we also have the CSV Conf submission, and that's almost ready to go. I just wanted to make sure, Jesse, that if you wanted to add any more things to it, because I know we talked about that.
Yeah, there's some stuff I do want to. I looked at it and it's good. I want to do a little bit of tweaking. I think to do that last 2 days, but I'll probably be doing that later today. So
okay. Yeah. So as soon as I get those comments, I'll submit it because it's due the 28th, but I want to get it in as soon as possible. Okay. So then we have this DevoLearn Flash Talk, which I actually did this week. So this went pretty well. The slides are available on the DevoWorm GitHub, and it went pretty well. It was an 8-minute presentation on the DevoLearn platform, which is this educational platform, which has the research part and the data science education part and the theory building part, and putting that all together. And they were interested in the theory building part because it was a lot of educational psychologists and psychology type people there. So I think it's worth. We're going to do this DevoWorm paper, which is still happening. I haven't been able to turn attention to it, but it's that we might go in that direction on that paper too. So that's a good opportunity to think things through. Then NeuroMatch 4, this is still TBA.
Are you going to be talking more about that experience at the next DevoWorm meeting? Or?
I mean, I don't know if it was an experience. I mean, like it was just a flash talk, and then I might reflect a little bit on it, like what I learned about, where we might go with the stuff. I mean, they had some good sessions, but they were a lot of like interactive, so it's kind of hard to. There weren't really any presentations per se that I can present on, but we'll talk about it then. So this is one of these things, growth form in the theory of deep learning, which doesn't really have a home. I'm trying to match it with some conference, but maybe it doesn't have a home yet, so that's fine. What else? This is probably not going to happen. I'll gray this out, actually. This is the Embodied Multimodal Learning Workshop, but we don't really have time for that because it's coming up pretty soon, and I haven't really even thought about it. But I don't know, maybe you've thought about it, Jesse, the Embodied Multimodal Learning Workshop. It's at ICLR, due March 1st. And I think there's it's an extended abstract, but I don't know what we would put there.
Yeah, I haven't done a lot with that yet, so I might kind of think of that.
Yeah, well, we'll see. I mean, we'll see closer to the deadline if we can make it or not. It's out there. It's like, so this is Cognitive Futures or AI Ethics. So this is the Envision conference. Is that something? Do you have an update on that?
No updates. It's currently, I haven't heard back from them. I think it's substantial.
Hello? You dropped off for a bit there.
Just saying no immediate updates. I'm just waiting on word back from them, and everybody can reply right now.
Okay. Yeah.
And reach out to me on Slack if you have any questions.
Okay. Then we have a bunch of things. I haven't heard back from this. We have a bunch of things that don't really have matches to them. This is something for DevoWorm. This is these NERC submissions have been submitted. We're waiting to hear back. This is the scientific understanding and representations abstract representations in the Observer that was submitted this week, or right, yeah, I think it was this week, and that is now submitted. It was submitted to Easy Chair. So again, this is like just an abstract, and then we'll get the main paper out, or I think it's just a talk, applying for a talk. So that's something we can do. Coming up, we'll hear back from that. I don't know, in a couple weeks maybe. We got Jesse. Oh, got two Jessies now.
Yeah, I'm adjusting something with my connection, so.
Okay.
Don't worry about it.
All right. Okay. Now this is the Gibsonian information paper. So this was submitted to CogSci, probably on I think the deadline was the 4th or the 5th, and so that's in review now. So this is, I wanted to bring this up because we talked about the Developmental AI paper. So it does have a section in Gibsonian information, but when we wrote the Developmental AI paper, the Baby Minds paper in the fall, we didn't really have this paper in place. So we now have this paper in place. And this, again, is something that we can change and add to over time. But this is going to be, I think this came out pretty well. We talk a little bit about redundancy of perception and some other things in there, direct perception, some of the theory around it, and the concept of this is information. It's a form of information. So we actually can update the Baby Minds paper with some of the things we've learned in this. And so I don't know what the odds are that this will be accepted to CogSci. It may be very low, maybe very high, I don't know. But we want to definitely work this paper in tandem with the developmental AI stuff, because I think it's sort of almost like a corollary thing. Like, that's one of the aspects of developmental AI is the Gibsonian information and with how you define that and everything. So this is the Baby Minds follow-up. That's kind of like linked to this A-Life submission. So this Euler cycles for life. This is something I'm going to write up and submit to ComplNet, which is a complex networks conference. It's just a paper on something I've been working on. I think Danielle is interested in collaborating on this, but that's coming up later. So Society and Ethics, that's completed. Then we have the fellowship application for AI now, which is a deadline of 3/1. So that's coming up. We have the ACM Collective Intelligence, which is 3/1. It's I think an extended abstract, so that's something too. There are a lot of extended abstracts due March 1st. We might have to make some decisions on that. And then finally, there's this Darwin Day blog post, which is actually done. And that's a DevoWorm thing, but I'm going to talk about it here in the meeting as well. I'm going to talk about a little bit today, but then I'm going to go over it more in the DevoWorm meeting in more detail, because it's kind of more related to DevoWorm. Okay. So that's our list. Is there anything we want to add to this list, or?
Not right now. There was the We Robot conference, but I think I missed the deadline on that, and I don't really have enough legal background to really contribute to myself. So, but nothing for me otherwise.
Okay. So, everyone, if anyone's interested in putting something on this list, you can go ahead and maybe make a number, numbering system as a sequential, and then put in fill in the details, and I can fill this column in, and then, you just put in the name, the submission, the venue, the deadline. If you're more comfortable posting it in Slack, then do so, and I can add it into this list. This is just a way for us to do it in one shot and see what our deadlines are coming up. These red marks are like things that are upcoming, like within the next few weeks. So we're actually doing pretty well on the red zone topics. When this is submitted, then the only thing in the red zone will be that we haven't submitted will be this. This has been submitted, so that isn't really necessary anymore. I think we'll have the envision thing, and then this is something I'm working on separately, and then this artificial life. So we'll be in pretty decent shape. So we're getting along with the system. I think it's working out. It's giving us a lot of. It's getting us very motivated, I think. So next thing I want to talk about is this synthetic daisies post. This is the Darwin Day post. So Darwin Day is just a cute little thing that they do every year. It's like an evolution awareness thing for scientific communication. Darwin Day, I mean, they don't worship Darwin, but it's just like, you have like, you reflect on Darwinian evolution, and, you promote evolution during that day. So I've been contributing for a number of years on topics related to this. Sometimes it's historical, sometimes it's computational, sometimes it has a very tangential contribution. So like last year I talked about Roger Sperry and the chemosensory hypothesis, which is something from neuroscience, which doesn't seem to have any relationship to Darwin, but I made a connection there, and you can read about it. I don't know if I have a link to it here, but if you go to this Darwin Day, this link here has like all the Darwin Day posts on this blog, which is like, goes back to like 2010 or something. Just every year is in here. It's just a matter of finding it. So that's that. I have like a keyword search here, but this goes through a number of recent papers and Twitter content related to evolution. So there's a lot of interesting stuff.
Oh, are you sharing your screen? Oh, never mind. I see it now.
Yeah,
sorry,
yeah.
It's my connection.
Oh, okay. So there's a lot of stuff in this post, and it's worth checking out, like a lot of the links, because you have a lot of content here that I've kind of put together for people. So this is there's a special issue of Royal Society of London B, and that's a journal. It's a biological journal, and they have a bunch of things on early nervous systems, or the origins of a nervous system. So there are at least 3 papers in this special issue. This is one of the papers, Elementary Nervous Systems. And so there are a bunch of papers in the special issue, but these are 3 that are really interesting. There are other top basal cognition, multicellularity neurons, and the cognitive lens. There's some other papers in there on like social behaviors and collective behaviors. It's a really interesting special issue. So you'll want to check that out. There's also a reference for online historical materials on Darwin, a lot of his personal correspondences and papers. Then there's this thing that I presented in DevaWorm. There's a group that simulated the evolution of plate tectonics. And what makes this study special is that they've done it over the last billion years. So, most attempts have been like the last couple 100 million years. And they've kind of shown the existing continents and how they've kind of moved around the Earth. This is like something that goes like from the time when there really weren't the continents that we recognize them today. And you've had this, these plates that have moved around and collided with one another and drifted apart. And you have things like, orogenies and rift areas. And those areas have led to the formation of new continents and old areas to break apart and form the continents that we know today. And so this is a really good simulation of this. There's a paper, of course, associated with it. And then in some of the discussion of this, I found this person who was working on mapping phylogenies or trees of life to models of early continental drift, or different, like maybe several hundred years ago when the continents were, say, like you had Pangaea, which was the single continent, or you had Gondwana and Laurentia, which are when we had two continents, and then the continents broke up further, and you had things that were sort of alive on this, say, on Pangaea, which then, they maybe existed across Pangaea or at in a region of Pangaea, which then got isolated, or they diverged because the continents split apart. And so these are, this is just kind of it's somewhat speculative, but it's also an analysis of this. And I haven't been able to find anything else like in the literature. There's an area called of science called phylogeography, which is area of evolution where they look at phylogenies and they also look at geography. So that's an area that exists in the literature, but I really haven't found anything quite like this. So it's worth following up on. Then there's some more stuff on nervous system anatomy, the evolution of new cell types at the lateral neural border. This is a nice paper that talks about brain anatomy and the creation of new neural types in different organisms, invertebrates and vertebrates alike. And this is a typical paper announcement on Twitter. And then there's kind of a shift to something called neutral theory. So we go from neural systems to neutral theory, and then we go back to neural systems. So it's a little confusing, but neutral theory is this idea that most biological variation is expressed in selectively neutral genes, and so is random in nature. And so it stands in opposition to the selectionist perspective, which a lot of people know pretty well, but not as many people know about neutral theory. Finally, I'm covering the work of Cassandra Extravor, who did doing this wonderful work on like the evolution of memory and someone called it Evo Devo Eco Neurobiology. And so it's just really good stuff. It's a nice interdisciplinary take on some classic topics, or even some really interesting novel topics. And then someone drew notes of this talk, so you can there are a bunch of links in here that kind of point you to all these resources, and so that's that post. And I think it's a really interesting, but you should read it, go back and read it when you have time. So it's the Synthetic Daisies blog, and I think I tweeted about it yesterday, so that's in there. Now I want to talk about I want to go on to the developmental AI stuff now. So we have this developmental AI. I've created an outline for this, and this is, of course, the topic that we're doing the Baby Minds paper on, and the Gibsonian information stuff fits into this. Maybe even the allostasis machine stuff too. It's kind of this umbrella of things. But I want to focus more on the developmental AI aspect. And I know we've laid out some of it in the well, it started with the developmental Bradenburg vehicles paper, which I suggest that you read if you haven't. And it kind of lays out how this can be implemented. It's a very broad idea. And then in the Baby Minds paper, we focus on it more in terms of the more tightly in terms of the mechanisms and more general mechanisms. So we use a developmental Bradenburg vehicle for that to illustrate it, but it doesn't have to be constrained to that. In this outline, and this is on the GitHub, the Oral Lab GitHub organization, this is sort of an outline of a very general view of developmental AI. We talked about this in the Slack as perhaps being like a preprint or something that we can publish that give us some sort of outline for this approach, and it'll be a very general approach. It doesn't matter what you can implement it maybe in any sort of environment you wish. It just has to have some certain properties and certain things we have to think about. So this is a place to host this theoretical synthesis. So the outstanding issues we need to think about are things like critical period in development, which I think we've developed with respect to the in the Baby Minds paper. And then we also have this developmental periods are facilitated by parentage-assisted development. This is something Jesse brought up in one of the meetings. You have this aspect of, like especially in the genetic algorithms approach, we have this idea of reproduction and producing new variants, developmental variants, but we don't have a parentage aspect to it necessarily. And so parentage, of course, can be thought of as kind of like supervised learning or assisted development. But the question is, we haven't really talked about that explicitly. Maybe that's something we need to flesh out for the A-Life submission. Jesse also brought up something about the stray cat analogy, which are the different trajectories in development that, a system can take. So, if you have a stray cat, you can teach it to behave like a domesticated cat, or, it can become a wild cat, or it can become feral. I remember Jesse talked about this in a prior meeting, but it basically boils down to this idea of having different trajectories in development. So depending on where you intervene in development, you can change the trajectory of development. At some point, it's your developmental potential disappears, and you're kind of locked into your environment that you've been in. So we have to think about this maybe more visually. What is it that how can we characterize this in terms of, and we talked about this with respect to contingency, developmental contingency. So you have this developmental contingency aspect where, we have, if some event happens, you have a limited number of outcomes that can come out of that event. If you make a decision early on, it can constrain where you can go in development. If you make a host of decisions, it really constrains you or locks you into a certain portion of the possibility space. So you can't say, for example, experience a bunch of things and then develop some other capability that's like way off on the other side of the developmental space. You're kind of locked into certain outcomes. That would be worth laying out either visually or maybe computationally. And then I think that relates to this second point where we're talking about assisted development. So, we're thinking about like development as like this autonomous process, which is generative. It's creating neurons and connections. And then you have this developmental freedom. So it's like there's this reorganization as you're learning things, as you're encountering them. But then there's also this assisted development. I should say that, we talk about parentage and development a lot, but that's only really in humans. The way we think about it, we actually, if you go to the animal kingdom or, the broader animal kingdom, you see all sorts of modes of development where you have everything from like animals that lay their eggs and leave them, and they produce massive numbers of offspring, but don't like assist them in their development necessarily. And then you have, organisms like humans where you have a very high level of parental investment. A lot of mammals are like that, where they will invest in their young and they'll give live births and they'll invest in their young. They have societies where they they shelter their young from the larger environment for, a certain period of time, and that assists them in the development. So humans are actually kind of an outlier in that respect. So they're not like, in a lot what I've seen from developmental AI, some of the approaches, especially like in the Baby Minds conference, is this sort of human-centric view of development. And so, or like a domesticated animal centric. It assumes that there's a lot of parental investment, which is, which is good, but it's also kind of, I don't know if it's really the way development works broadly. It doesn't have to be, there doesn't have to be that investment. And then you have this question of why do humans invest so much in their offspring? And then that leads to a whole host of other questions. And so if you're building an AI, which is a very general thing, maybe you want to build a general intelligence, then that assumption needs to be examined more closely. Why do you have parentage? Although I think it's a great idea, in general, and I think it's necessary to kind of understand, the power of development. It's also something that isn't just, it's something you see in humans, it's ubiquitous, but it's not so ubiquitous if you're looking at, say, like C. elegans or, some invertebrate species where they don't do that, or even in fishes. So, I mean, it's something that it opens up. It's an interesting topic. We can talk about it later. I think those areas. How are you doing on the notes, Jesse? Are you taking notes on the different parts of it? Okay. Then we have this topic: switch modes and convergence constraint, and that's this idea of path dependence versus innateness. And I'm not sure what that means, but I think it was like where we had this. We go back to this area of developmental or of like developmental contingency, and then this is something versus sort of an innateness or something where the feature is locked in from birth, where it's expressed from a set of genes where they unfold in a certain order in development. So like innateness, and I know that Tony Zador has talked about innateness, but I think when he talks about innateness, it's largely about the sort of the things that are already there. So you could just have you could put something on board a robot, say like a circuit with a certain topology, and then it could vary, and then that's of course your innateness. I think we're thinking of innateness in some of our developmental AI work more as like having a sort of a genome, and he talks about genomes in his work, but like having a genome that gets expressed, but in a very developmentally explicit way. So you have like certain genes that are that express at certain times in development and bring things online, and then from there you can vary how they're expressed, how they interact with, say, like mental representations or with the environment. So there are a lot of options for that. So that's that topic. Then there are these analogies and mathematical parallels. So we have this epigenetic landscapes versus gradient descent. We talked about this several weeks ago, where we had a diagram of like these, what are called epigenetic landscapes. These look like landscapes with hills and valleys. And they're actually trees because you have like these valleys, but they branch. So they start at the top as a single valley and then they branch out. And the idea is that your developmental system can travel down these valleys or these channels, and they hit like decision points and they move down, and then the single channel canalizes, as they call it, into many different channels over the distance of this landscape, and you end up at the bottom of the landscape where you have a bunch of potential channels that the system can follow, and you end up at some certain point, some certain developmental outcome. So this is something that's been developed by Conrad Waddington back in the middle 20th century, but people have actually put a very explicit computational cast on this in the 21st century. There are a number of papers that kind of lay out a computational model of these landscapes, and so this is something that's been quantified. We can contrast that with something called gradient descent. Of course, we know this from machine learning, where there's energy minimization as opposed to quantitative trajectories. Although you can have quantitative trajectories, it's just that the point of gradient descent is energy minimization. Whereas with epigenetic landscapes, you have this sort of, predetermined movement towards the bottom of the landscape, but it just depends on where the system goes on that landscape. That's important. So we need to kind of figure that out, how this works with respect to both of those, because they're actually both important. I don't know, maybe I'm inventing a distinction there, but I think we discussed it, and it's interesting, but we don't really have an answer to that. So that's something that we could talk about more as well. In terms of potential tasks, we have theory development, which is, Anson, but other people can do it. He would be good for that particular thing. And this involves fleshing out and defining different components and their relations. So questions like this, figuring out how they fit together, or some of these other issues in, development, parentage and parental investment, trajectories in development. And then I didn't even put anything about Gibsonian information in here, but it is very tied into this. So we have the Gibsonian information paper. People want to read through that and then think about this problem. That's a good way to go too, because it does raise a lot of associated issues. Computational verification and principle testing. This is inspiration from the free energy principle. This is something that's probably later on, once we flesh out a lot of these conceptual issues. But this is something that could be taken on by someone. We developed a number of candidate platforms for this, so we have a number of different ways this has been implemented already. Being able to test between those or implement them, and think about, the types of things the types of questions, say, that would involve, some sort of gradient descent or free energy principle associated metric, to look between these different implementations. That would be good as well. And then the real world impacts. So this is Gary Marcus's Robust AI, Lisa Feldman Barrett Clinical Approaches. So this is and I'm taking these from notes that I made from some of our earlier discussions on this. So this is why they're kind of they're not as organized points as I would like. But the real world impacts. So this idea about robust AI, this is something Gary Marcus has talked about. There are other people who have mentioned other things in this area. So basically it's applying this framework to some real world applications. So robust AI is something people are talking about in the broader community. Can we link our work into that? That's what this means. And so that's important when you want to publish something and you want to get people interested in it. You want to, appeal to some of the outstanding issues of the day. So then I have next steps. And I talked about potential tasks, but these are actually maybe more concrete next steps. So some of the things we need to do here to get this going, I think aside from all of these different conceptual topics and sort of things that we need to do in terms of theory development, is to really differentiate developmental AI from regular AI. So, when we talk about development, what do we mean? Do we mean emergent morphogenesis? Do we mean, teaching like a naive agent something and allowing it to develop into an adult agent with full capabilities? Or are we talking more about sequential acquisition, which is where you learn a task in its component parts, and that's development because you're learning. You want to ask the question, how does an agent learn how to grab a cup and drink from it? Well, that's something you could teach. It may or may not be development, but that's the way people have thought about that problem, is development being how do you teach that in pieces? What is the sequence of things that an agent needs to acquire to be able to do that action? And so, those are all things that kind of, we need to kind of differentiate between. So people will ask I think of development more as a sequential acquisition. And we're that's part of it, but we don't really talk about that explicitly. The other thing is the things that when you submit something in this area, people are going to ask questions about. So we should have the answers ready. And then, what is Dev AI? We need a guiding document. So this is what I was talking about with this preprint, which is to lay out all the issues, lay out some of the potential solutions, deal with these questions, like this question. What do we mean by developmental AI? How does it differ from regular AI? Why do we need development? And then put them into this, I say a wiki here, but I think a guiding document like a preprint is good to start with. And then we can actually examine some of these conceptual components and fit them together. So we could put a wiki together, maybe in conjunction with the preprint, for some of the harder topics that, maybe we don't want to get into in the paper, or maybe that we can add to later. I think there'd be a nice synergy there. But once you start to, once you lay out the vision, then maybe the wiki would be somewhere where you could link some of these topics to some of the things that have been implemented. So, like I said, there's a Hebbian learning version, there's a reinforcement learning version, there are other versions of this. And then there are other things like the metabrains, which we could also apply these principles to. And then the wiki would tell you kind of how that works more explicitly. And then different papers and posts to flesh out this ecosystem of concepts. So already kind of there with the Gibsonian information, and we did a paper with respect to A-Life last year. The A-Life conference, there was a workshop, and we did a sort of a MetaBrains version of this. So there are a lot of papers we're already kind of working on that are kind of related to this. The question is, how do they fit together? We haven't really developed it in that way. We've just kind of said, okay, this is Gibsonian information, but we haven't really made an explicit link to the developmental AI aspect. So I think that's worth mapping that out. How do they all fit together? So I'm gonna present some papers in a little bit here, but I wanted to ask Jesse if he had any thoughts about that, what I just talked about.
That's really good. I think they capture a lot of stuff. I think it fleshes out really well. I think it strings together a lot of the different strengths that we've been talking about for some time. So I think that really lays out kind of there's so much to do in this area, and I think that'll be I don't know what the rest of the lab is going to be doing over the course of the year, but I feel like that's sort of like a giant. There's a lot of things that will be going into, that could be going into this, and I think that's a very good overview of sort of where things are right now, and there's a lot of it does a good job of capturing sort of the different theoretical things to sort out, and then ways we can develop upon that later. So it's good. I think there's a lot of it's something to be mined quite a bit and refined, and I think it's a good overview.
Yeah, thanks. Yeah, I mean, this is something, it's a lot of stuff to digest at once, but I think if we we'll be updating this README hopefully with more focused points, and we'll be putting some of these on the task board as they sort of get sharpened into issues, because right now there are a lot of things that be hard to deal with as GitHub issues, but this is the process. You boil it down and get the issues out, then you figure out where you want to go. But you have to have this outline first, and maybe we can use this outline roughly as the organization of the preprint. So I will revisit this. If you want to contribute, you can push to this README in Developmental AI, or you can just put it into Slack. We can do things through Google Docs, and then concentrate some of the issues here. So there are a lot of ways you can contribute if you're interested, or we can talk about it in future meetings. Then we'll be doing this A-Life paper, so we'll be revisiting these topics and then looking at that when it's been submitted and see where we are with how these things develop. Because it's like there are a lot of ways these could go, as you can tell. They're just kind of like points, but we need to figure out how they fit together and how they get solved. Things like, nurture, or, innateness versus nurture, or some very specific topic, like, or controversy, or something that could be a controversial thing. We have to deal with it in an effective way, or else people, again, they're going to raise questions when we send it for peer review. They're going to say, well, what do you mean by this? This isn't really the way people think about this. So it's just, I know, like, maybe a lot of you haven't had a lot of experience with peer review, but peer review can be very brutal in that sense. And especially if you run afoul of, like, conventional wisdom, it can be somewhat, very, very, people can be very rough. But we'll keep working on it. So I wanted to finish up today. I wanted to talk about some papers, and I'm going to switch gears from development. I'm going to talk about virtual reality. I know Jesse's been interested in that for a while. We haven't really talked too much about it, but I'm going to talk about some papers on that topic. So the first one is this. It's a Gizmodo article. It's a conference paper. They're kind of covering this conference paper. Steering a balloon with sound waves can be the secret to touching objects in VR. So this deals with, like, people doing haptic interactions in VR. So one of the problems that they've had in VR is, like, making the stimuli real. So, like, you have your headset on and you have maybe some pinch gloves or touch gloves, and they make these interfaces where, they can simulate different things in your field of view or on your, touch, what they call haptic sensation. There are a lot of things to figure out in this to provide, like, a fully immersive experience. So if you're in a VR system, if you think about watching television, which is actually a form of VR, it's not that immersive, but it's immersive enough. It's immersive in terms of the narrative. Like, you can get engrossed in a television show, or if you have a large screen television, you get engrossed in the image on the screen. You might be watching a nature scene, and it might help you, cure your depression because you're watching this nice sunny scene on a beach or in a woods. You're watching a babbling brook, and it's like, there's this immersion that happens, but it's not like the kind of immersion that we seek in VR. In VR, a lot of times, or at least the vision's been to immerse people fully into this world. And so you're actually generating different things in the field of view, or in the, things you can touch. And so full VR, which is different from, say, like augmented reality or mixed reality, full VR is creating this world that's just basically immersing the person. And if you go to the holodeck in Star Trek, that they have they live in this scenario. They walk around and they interact with people, and there's all sorts of things going on. So it's very immersive. But the first step to this is to create stimuli for, that you can interact with. And so in this case, they have this. So the ultimate goal to making virtual reality feel more like reality is letting users physically touch non-existent objects in a VR world. So you have this, say, balloon, or you have this cup, or you have, like, a building that exists in VR. You can see it, but you can't touch it like a regular building. It's just something that's there as a visual stimulus. And so the immersion might be pretty weak if you can't touch it, or if you can't examine it, or it doesn't behave like an actual object if it floats in the space, for example. So you want to make these things. One of the ways that you can make these things more immersive is by integrating cues across different modalities of your sensory systems. So in this case, they're trying to figure out how to basically make something you can reach out and touch. And so In this case, they're experimenting with steerable helium balloons. So they're actually using some physical, they're using a physical simulation. You can steer these balloons, and the balloons have a certain physics to them. They have a certain, shape and form, and then also interaction with the physics of the atmosphere, of the air around it. And then you're pushing on the balloon, so the balloon itself has a certain stiffness and viscosity to the movement, and there are all these properties that you can measure that your brain actually approximates and registers as something real versus something that's not realistic. And so that's how immersion happens. Things have to be realistic. And so if you don't have a realistic, and this has been the problem with a lot of this in video games, where they simulate something that's really highly unrealistic. Like the simulation is done really poorly. And so, you don't feel very immersed. It's almost like a joke. Like they used to, when they did racing games, they would have like a steering wheel that you could buy for the console, and you would drive it, and they'd have rumble strips on the road or whatever, and you'd drive over them, and the steering wheel would rumble like you were going over this thing in the road. And so there was this transfer of haptic information into the nervous system. But the problem is, if you don't pull that off, if you don't synchronize it with the visual stimulus, plus if it doesn't feel like something that you would actually feel in the environment, then it's not really believable. And so people would make fun of it on internet forums and things like that. But the reason is because it doesn't feel real, right? So they're using this steerable helium balloon technology. So this is something they're testing, and they're trying to make it seem as realistic as possible. They're trying to simulate things, a general sense of touch, things that you can control that, maybe make something seem more realistic or it have this richer, property to it. So what makes virtual reality so compelling? And then the statement is its ability to transport a user into any experience. So, which makes facilitating synchronized physical interactions in the real world so complicated. So a system needs not only to match the movement of the VR user's hands, it also needs to be able to quickly move and position itself in a way that it never obstructs, interferes, or causes injury to a user. So these simulations that you make of the environment, they can't be obtrusive. They have to move with the objects, and they can't get in the way of the user. So, we don't want to use something rigged that's highly obstructive. And a lot of VR, is pulled off with like head-mounted displays. Sometimes they use what they call a cave, which is where you have a bunch of video screens in front and along the sides of the user, and then like maybe an audio system on the bottom or on the top, and you're giving them information from different directions. But even like a cave, although it's immersive, it's very artificial in terms of where you are. You can't do certain things in a cave, and so there are a lot of things that you have to kind of play with and make them more realistic. So Star Trek solved this problem with hologram force fields that can appear and disappear anywhere in the blink of an eye, but that technology is firmly rooted in science fiction and centuries away from becoming a reality. So researchers at the University of Tokyo, one of the labs at the University of Tokyo, possibly inspired by a birthday party, have developed a similar solution built around free-floating, neutrally buoyant helium balloons. In a paper published in December of 2020 in the SIGGRAPH Asia conference, Balloon Interface for Midair Haptic Interaction, the researchers detail an elaborate 360-degree rig that uses a series of ultrasonic phased array transducers to generate inaudible sound waves with enough force to push a floating balloon around and precisely control its motions. The setup also includes a pair of high-speed stereo imaging cameras to track the position of both the balloon and the position of someone trying to interact with it. The resulting experience is a physical object that a user in virtual space can touch and feel while trying to reach out and interact with a virtual object in VR. The balloon can be quickly repositioned so that it aligns with a virtual object and creates a sensation of a touch interaction, even if the weight, firmness, and texture of the balloon itself don't correlate to a virtual object. right? It has to provide matching resistance, but if it doesn't, it can't do that for certain objects. So the balloon isn't going to provide any kind of matching resistance if someone is touching a virtual brick wall, say, for example. The fact that any touch is experienced should help enhance the believability of VR. So the other advantage of using helium balloons is that a VR user's unpredictable actions results in them accidentally hitting or colliding with the balloon. Nothing is going to get damaged. So they want to put these things sort of in an environment, right? And they want to use something that's inobtrusive. But they also want to be able to simulate a fair number of objects. But things like bricks, they have a very high stiffness, and, they're very, if you can punch a brick wall and your fist will, your bones will shatter. So it's very hard to simulate something like that. But if you're simulating something that has a softer, Young's modulus and has other physical properties that are something you could approximate with a balloon, then this works for you. So, I've worked with haptics a little bit, and basically the idea is to have like sort of a medium level sort of surface that you can manipulate. So you can actually modify the surface that you're simulating by, adding in some stiffness or decreasing the stiffness or doing things to it that make it, try to approximate what you're trying to manipulate or touch. Certain things are going to be harder to simulate than others. So a brick wall is harder to simulate than, say, like a pillow. Or, it depends on what you're using as your analog, of course. But that's the idea here. So you want to be able to take a bunch of surfaces, characterize their physical properties, and then simulate those in a way that, allows people to, you can do this with an interface that gives you feedback, or you can do it with actual objects that also give you feedback. So this is what they're trying to do here. This is the paper, of course, a balloon interface for midair haptic interaction. So this is the balloon on a rig. So the idea is this is a proof of concept. They're just grabbing it and manipulating the balloon, and it's supposed to be an analog for different types of physical objects. It's not meant to simulate all objects, but it simulates a range of objects we can introduce, and then we can measure how people interact and if they think it's realistic. So this is, there's a tracking system that's involved in this as well. You want to be able to track things in space because we interact with things in space as well as, when we touch things, we interact with them in space. We register them in places, and they have to co-register with those locations in the virtual space, or else it's somewhat useless. So there are a lot of things when you're doing these virtual simulations you have to keep in mind, like, and this goes, I think this goes back to maybe some of the stuff that we're doing with Gibsonian information. And that is that you have all these, when you think of like an organism or you as a human interacting with the sensory world, you have this sort of, you have to think about how immersive the world is. So in other words, you have like, when I'm sitting at this desk, I can touch a bunch of things around me and they have a certain feel, stiffness. I can move them with a certain ease or unease, as it were. And I get all this feedback, and it's natural because the objects are physical and I'm used to it. I've learned how to interact with them. Unlike, say, like a newborn baby, you wouldn't know how to interact with a cup. I can interact with a cup and bring it to my mouth. Now, when you're in a virtual environment, you have to reinvent this sort of space in front of you. You have to think about modeling that space. So, but it's harder than it looks because you don't want to just model the objects as like these physical things. You want to be able to track the objects in space relative to the individual, and you want to be able to simulate the surface, simulate the sort of the weights, and other factors, and it all has to be registered in space because you're in a virtual environment, you're actually simulating these objects, and then they have to behave like real objects. If they don't have this, if they're not weighted by gravity like a real object, then it's not believable. It's like if you pick up a brick and it feels like a beach ball, for example. That's not really something that's gonna. I mean, in some cases, if you're trying to invent like a fantastical environment where you have, say you want to build an environment that's like a fun house, and the point is that you have objects that you can pick up and they're really light. And I think you've seen this with bricks, where they're like certain types of bricks that are like styrofoam. They're made of styrofoam, but they look like bricks. And that's a brick. And you expect to pick it up and it to be very heavy, but it's very light. You pick it up, oh. That's kind of what we're dealing with here. And it's sort of that sort of illusion that we have a certain expectation for certain objects, that they have a certain weight, they have a certain stiffness, they have a certain this and that. They have all these properties, and we verify it with vision and with touch. And so then we can pick these objects up, manipulate them. But, we want to make sure that they have the appropriate properties that we want. And again, like if they're this sort of fantastical environment, maybe it's not so, maybe we want to change them in a way that surprises the person who's manipulating it. So I think there are a lot of tie-ins here with Gibsonian information, and I haven't really thought about it until just now, but it's definitely something we could, this is something I think we were trying to do in the paper. We didn't really have space for it. We might actually have space for it if we do the revision, because in the CogSci format, we're not at the page limit. So we might add some things in on that. But I want to think about it a little bit more before we dive into it. But I definitely think it's something we should put in the notes for later.
Yeah, I agree.
And so, actually, let me see this last part here. Okay, I thought they talked about affordances. They really don't. But that's another thing, too, is this affordances aspect of it. So, again, like when you have a brick and it has the properties of a brick, or if it has the properties of a styrofoam brick, or, like some ceramic brick, those are, there's an affordance there. So the brick has an affordance that tells you something about its properties, right? And then you can sort of, break that affordance in a way by simulating it wrong, or by intentionally simulating it wrong. So, you have like, we think of affordances as these things that help cognition along. Well, that's kind of the idea, is that, things in the real world, they have affordances, they have handles, or they have a certain set of properties that we learn to associate with that thing. And if those objects break down that relationship, then it's, and this is something you do wonderfully in VR. You can actually break those relationships down enough so that it really confuses the user, or confuses the subject. There are all sorts of tricks you can do with, like, visual perception as well. A lot of like visual illusions that you can do that, like, play around with affordances, play around with sort of your common sense of like how things should be in the world. So you learn things in a certain way, like you learn, for example, that feathers can float in the breeze, but if you show a feather that's like immobile in the breeze, it's kind of confusing to people. And so there's a lot of things you can do with visual illusions in VR as well. You were going to say something?
Excuse me. I'm sorry?
You were going to say something?
Just that I agree. I don't have any like interesting comments, but I think this is all like, I definitely would like to do more things with virtual reality, and I feel like that's, I don't know where that fits in with the scope of things in terms of what the lab's going to be doing, but I'm definitely, as I kind of mentioned in previous meetings, and I'll stay here, I think virtual reality is going to give it a lot of opportunity to be a unique testing space for a lot of these things, and also, I have some friends in this field, or like in this area or adjacent area, where they're doing like sort of not exactly clinical work, but sort of adjacent clinical, or like there's VR therapy stuff, but also sort of like cognitive, not really development, but like cognitive, I don't know, combining like various elements of neuroscience and cognition and VR stuff. So I feel like there are some interesting applications for this too, and at some point, I feel like I should go into, like, I should really do I'll make a note in GitHub to I should do a presentation on this sort of what I'm talking about here, like this sort of people I know are using VR to do things in this field. So
yeah, that would be great.
Yeah.
Let me go to the next paper. There's a second paper, and actually I have something else here. Let me see. That's actually something I think from a while back, but actually it would remind us of this quote from Busaki: "Brains do not process information; they create it." That was from a couple weeks ago, and so that's like something that if we keep in mind for this the past paper and the next paper. So this next paper is the plausibility paradox for resized users in virtual environments. People have done I've seen papers on this every now and again where and a lot of people know in virtual environments that you usually use an avatar. If you've ever been in Second Life, you know that you create an avatar and you can see the avatar moving. Sometimes if you're it's a first person avatar and you're the avatar and you're seeing it from the perspective of the avatar's eyes, and you can look down at your body, your virtual body, but the avatar is basically, in this case it's like a third person avatar where you can see yourself moving around. And so you want to, what you can do in VR is control the scale of the environment relative to the avatar. And so it's interesting, this is an interesting aspect, because if you use VR for a while, you tend to see the world in a certain way. So you're manipulating the world on your computer screen. There's a certain spatial scale you expect. If you move your mouse a certain distance on the screen, you expect things to happen in a certain sort of way, in a certain sort of magnitude of change, right? So that's something that you don't think about too much, but happens when you're using these environments. The same thing with navigating a virtual environment. You're running in a virtual environment and you expect to cover a certain amount of distance, and you plan it out in your head, so you know these spaces. And then if you maybe shift it, or if it's maybe different from the scale that you're used to thinking about, then it makes it a little bit more frustrating and maybe even breaks down, some of these mental models you have of the space. So this paper, why don't we get into what they're doing in this paper? This paper identifies and confirms a perceptual phenomena. When users interact with simulated objects in a virtual environment, where the user's scale deviates greatly from normal, there is a mismatch between the object physics they consider realistic and the object physics that would be correct at that scale. We report the findings of these two studies investigating the relationship between perceived realism and a physically accurate approximation of reality in a virtual reality experience, where the user has been scaled by a factor of 10. So the avatar or the user is scaled by a factor of 10. So they're either really small with respect to the environment, or they're really large, or they're normal sized, or it could work the other way. But basically there's a scaling factor that's different here. Study 1 investigated perception of physics when scaled down by a factor of 10. Study 2 focused on enlargement by a similar amount. Studies were carried out as within subjects' experiments. In the true physics condition, the objects, when dropped and thrown, behaved accurately according to the physics that would be correct at either reduced or enlarged scale in the real world. In the movie physics condition, the objects behaved in a similar manner as they would if no scaling of the user had occurred. We find that a significant majority of the users consider the movie physics condition to be the more realistic one. So this is in this case, it's actually a little bit different than what you would intuit. In the true physics condition, the objects, when dropped or thrown, behaved accurately according to the physics that would be correct at either the reduced or enlarged scale in the real world. So in other words, if you're dropping or throwing objects at two different scales, the real physics would be if I scale myself up, the physics scale corresponding to that. If I scale myself down, the physics scale corresponding to that. So it requires you to have two mental models of the physics for those two different scales. And, to make analogies between the two. In the movie physics condition, which is like, a fantastical kind of physics where, a movie physics are like, basically there's the objects behave in a similar manner if no scaling of the user had occurred. So that just requires people to have one model of the physics, even though it might not be realistic in that sense. However, at a large scale, many users consider true physics to match their expectations, even if they ultimately believe movie physics to be the realistic condition. So there's a difference between the expectation and the realism. So that's interesting. We argue there are findings of implications for many telepresence and VR applications in simulating physical objects in abnormal and especially small scales. So people simulating things like the nanoscale, or maybe things like manipulating things in the universe. This would be useful. This is something called the body scaling effect in the literature. And so if you want to look into that, there's some references here. You can look at body scaling effect. And so this is the first-person perspective from the subject's point of view at the start of the experiment. So this is the book Tales of the Sea. This is a book that if it was sitting on your table, you would look down on it, and it would look, like something you could touch with your hands. But in this case, it looks like a huge table. It looks like the size of the table. Coke can, similarly, is misscaled. And so you can see how that scaling, it's almost like you're a Lilliputian. You have the book, the book where they have the Lilliputans in it, the little people. And, the little, they're just like miniature versions of humans, and they, this is their world. You're shrunken down, and you have these objects that you expect to be a certain size and ability to manipulate are now these huge things. Honey, I Shrunk the Kids would probably maybe more a better example, because they're actually like walking through like a backyard that's now become this jungle. So you're scaling your perception of the world accordingly. And so the question is, does the physics behave in a way? Oh, he mentions Honey, I Shrunk the Kids in the paper. My God. Incredible Shrinking Man. All these things. So this is basically the idea here. And this is important in telepresence, because you're manipulating things using tools, and you're manipulating them long distances. So you have to be able to tell when you see something in a virtual environment, if you're going to manipulate it, what the response of the tool is. So if I use a tool to manipulate something in a virtual environment that's mapped, say, to something in a real environment somewhere else, I have to know what the physical properties of that distant object are. So this is another example where they're looking up at a table, which you would just look at like in your line of sight, but now you're looking up at it like it's this huge thing. And so this is body scaling, environmental cues, and kind of walks through a lot of these things. Presence and plausibility. So there are a bunch of concepts that are associated with this, such as immersion, of course, presence and plausibility. This is Mel Slater. In Mel Slater's classical definition, the level of immersion refers to the level of technical fidelity of the VR system. So it's vividness of graphics, resolution, field of view. And like I said, in the case of touch, it's the surface and how realistic it feels. In addition, the realism of the user's response to the VR system depends upon two orthogonal components: presence or place illusion, and the plausibility illusion. The PI, presence or place illusion, refers to the sensation of being in another place, whereas PSI, or the plausibility illusion, refers to the perceived credibility of the virtual scenario or experience. So this is the illusion of being there versus the realness of what is happening. And so PSI depends on the extent to which V can produce authentic responses for user actions. For PSI to occur, participants must perceive themselves as beings that exist in the VE, the virtual environment. User actions must elicit actions in the V, and the V must acknowledge for the user. So when virtual characters react to the user, if you have a virtual counterpart or some object, they have to respond in a like way, in something believable. Again, a cause and effect type way. In addition, the V should match the user's prior knowledge and expectations. And this is something they call coherence, that refer to aspects of the V that contribute to this PSI, or this plausibility illusion, such as virtual humans and the behavior of virtual objects. They argued that although immersion of a technical attribute that affects PI, coherence is a similar technical attribute affecting PSI. So immersion and coherence are sort of the counterparts to those two things. So I talked about this in this virtuality talk that I gave at NeuroMatch, and I didn't really spend a lot of time on this, but I might actually revisit a lot of this. And so the phenomenon studied in this paper can also be referred to as a coherence fidelity mismatch. The logic expected by the user is mismatches of more faithful representations of reality. It is expected that coherence differs from reality in, for example, fantasy games or other entertainment where PSI is maintained even when unearthly phenomena are taking place. However, we consider the mismatch studied here to be specifically interesting due to the implications for telepresence and VR. So this is a very interesting topic. We should revisit this, and I think, again, this has a lot of applications to the Gibsonian information and maybe some other things related to virtuality and things that we can play with in the future. And also it has relevance to things like Bayesian modeling. A lot of the multimodal modeling and multimodal fusion work. There's a paper by Mark Ernst where he does like this in a Bayesian, takes a Bayesian perspective on this, where he models a lot of sensory information and the internal model that you're using to integrate it in a Bayesian way. And this is a classic paper. I'll have to pull that up maybe next week. We can talk about it. But there are a lot of different interesting avenues we can explore here.
Yeah, it's good. Good stuff. I remember we talked. I know the that paper or the bias thing, but I mentioned in the different group, so it's good to see that paper, and it touches on a lot of things I learned about myself. So it's good to hear about that.
Yeah. Okay. Well, thanks for meeting this week. Next week we'll recap our prior meeting, and we didn't really do that today, but we kind of did. But and again, people want to bring things to the meeting. You are more than welcome to do so. So give me a heads up on Slack about things you want to talk about. But otherwise, have a good week, and see you in Slack.
Yep. See everybody. Week and weekend.
Yeah.